How does the location of a digit in a number change its value? We see the number 3 and 3 blocks. How does the value change when the digit 3 is moved one place left? When the 3 is moved one place left, the value of the 3 is 10 times greater. It takes 10 3s to make 30. Likewise, when the 3 is moved one place left again, the value of the 30 is 10 times greater. It takes 10 30s to make 300. Since each time a digit moves left in a number, the value is 10 times greater, we can use the relationship between multiplication and division to think about the value of the number each time we move right. When we move right, we divide by 10 to see the value. The value is 1/10 the original. If this digit 3 moves right, then the size of each block is 1/10 the original. The value is 3/10. If the digit 3 is moved right again, the value of the number is 1/10 of 3/10. The value is 3/100. And notice the blocks are also 1/10 in size. If the digit 3 is moved right again, we partition each hundredth into 10 equal parts, making 3 thousandths. These thousandths are very small. So as we move a digit left in a number, the value is multiplied by 10 and is 10 times greater. When the digit moves one place left, you can see that the block is 10 times bigger and it's now worth 1/100th. We can move it left again. The block is 10 times bigger and it's 1/10th. We can move left again. It's 10 times bigger and 1, then 10, then 100, then 1,000. So as we move left in a number, the value is multiplied by 10 and is 10 times greater. When we move right in a number, the opposite happens. Each time a digit moves right, it is worth 1/10 the value. In other words, we partition it into 10 equal parts, and one of those parts represents the quantity to the right. This would be 1/10 of 1,000. This is 100. 1/10 is 110. 1/10 of that is 1. 1/10 of that is 1/10. 100th and 1,000th. They're very, very small. So how can I use this to solve place value problems? Let's say we represent 4/10ths this way. If I move the digit 4 one place left, it will be 10 times bigger. That means my representation will be 10 times bigger, and I can represent this move with the equation 4/10ths times 10 equals 4. If I move the digit 4 two places to the left, it will be times 10 times 10. In other words, 100 times bigger. That means my representation will be 100 times bigger. And I can represent the move with the equation 4/10ths times 100 equals 40. We can also move digits right in a number. When we move the digit 2 one place right, it will have 1/10 the value. The value is divided by 10. That means my representation will be 1/10 smaller, and I can represent the move with the equation 20 divided by 10 equals 2. What if the 2 moves 2 places to the right? When we move the digit 2 places right, it will have 1/10 and 1/10, or 1/100th the value. The value is divided by 100. That means that my representation will be 1/100th of the original size, and I can represent the move with 20 divided by 100 is equal to 2/10. So let's use this to solve a new problem. Let's say we begin with 3 thousandths, and we move the 3 one place to the left to the hundredths place. This is the same as multiplying by 10. Each of the thousandths are 10 times bigger when we move left. We have 3 hundredths now. We can record this with an equation. 3 thousandths times 10 is equal to 3 hundredths. So let's use this to solve another problem. Let's say we begin with 6 and we move the 6 one place to the right to the 10ths place. This is the same as dividing by 10. Each of the 6 ones are 1/10 their original size when we move right. We have 6/10 now. We can record this with the equation as 6 divided by 10 is equal to 6/10. There's one more very important place value idea to consider. We do not have to use a specific place value block to represent a specific place. Let's look at some examples. So far we've been using this block to represent 100, but we could use it to represent any place. Let's pretend this represents 1 instead for a minute. If this represents 1, then if I move the 1 to the tens place, it would still be 10 times bigger. Whoa, that's a big 10. This is 10 times bigger than the block we just labeled as 1, so this represents 10 if the flat block represents 1. But what if we call this block 1 and we move one place to the right? When we move right, the size of the block will be 1/10 the size of the original block. We can represent this with the equation 1 divided by 10 is equal to 1/10. And if we call this block 1 and we move 2 places to the right, the size of the block will be 1/10 and 1/10 again. We can represent this with the equation 1 divided by 100 is 1/100th. So we know that each place we move left, a digit is 10 times bigger, and each place we move right, the digit is 1/10 in size. Let's use this to help us solve some problems. If Katrina used this model to represent 2/10ths, which model should she use to represent 2/100ths? Pause the video and think about how you would solve this problem. Then push play. To change 2/10ths to 2/100ths, I have to move each digit one place to the right. So the size of the number is 1/10 in size. Which model is 1/10 of the size that Katrina created? Answer choice A. Here's our next problem. A digit is underlined in this number, 946,738. Which number below has a 6 with the value that is 1/100th the value of the 6 in the number above? Pause the video and think about how you would solve this problem. Then push play. We can see that the 6 is in the thousands place. So we have to think, where would this 6 be if its value was 1/100th of 6,000? If it were 1/10th, it would move one place to the right. And if it is 100th, it would move 2 places to the right. So I need to find the answer choice where the 6 is in the tens place. Which answer choice has the 6 in the tens place? Yes, answer choice B. Our next problem, which of the following expressions has the least value? Pause the video and think about how you would solve the problem. Then push play when you're ready to continue. In each of these answer choices, the number is being divided or multiplied by 10 or 100. Remember, when multiplied by 10, the digits move left one place, and when multiplied by 100, the digits move left 2 places because 100 is 10 times 10. Likewise, when the digits are divided by 10, they move right one place, and when they're divided by 100, they move right 2 places. So let's find the value of each answer choice so we know which has the least value. 241 divided by 100 means all of the digits move 2 places to the right. So the value is 2 and 41/100ths. Answer choice B. 2 and 41/100ths divided by 10 means moving one place to the right. So the value is 241/1000ths. Answer choice C. 241 times 10. This means that all the digits move one place to the left. And the value is 2,410. Answer choice D. 2 and 41/100ths times 100. Means that all of the digits move 2 places to the left. So the value is 241. Now we have to decide which value is the least. Answer choice A is between 2 and 3. Answer choice B doesn't even have one whole. It's smaller than 1. Answer choice C is bigger than 2,000, and answer choice D is bigger than 200. Since all of the answer choices except B are bigger than 1, then B has the least value. Here's our next problem. The area of South Carolina is about 32,000 square miles. What is another way the amount of square miles can be represented? Pause the video and think about how you would solve this problem. Then push play when you're ready to continue. So we need to test each answer choice to see which one will equal 32,000. It looks like all of the answer choices are multiplied by 1,000. When we move one place left, the number is 10 times greater. 2 places left is 10 times 10 or 100 times greater, and 3 places left is 10 times 10 times 10, which is 1,000 times greater. So for all of these answer choices, we will need to move 3 places left. So let's try answer choice A and move 32/100ths 3 places to the left. So answer choice A is 320 square miles. That is not the area of South Carolina. So we can eliminate answer choice A. Let's try answer choice B. We're beginning with 3 2/10. We are multiplying times 1,000, which is times 10, times 10, times 10. We move the digits 3 places over, and we see that it's 3,200. That is also not the area of South Carolina. Let's try answer choice C. Is 32 times 1,000, which means we're beginning with 32 and we're moving 3 places to the left. Which is 32,000. 32,000 is the area of South Carolina. So we're going to call that the correct answer, but just for good measure, we'll go ahead and check out answer choice D. Answer choice D is 320 times 1,000. So we're going to move 320 3 places to the left. And we get 320,000, which is much bigger than the square miles of South Carolina. So answer choice D is also incorrect, and that verified our answer choice C. Now your teacher is going to give you some problems to try on your own. Just remember, the number and blocks are 10 times bigger each place that you move left and 1/10 in size and number each time you move right.